Alright, class, let's talk about the assignment I gave you. The task was to write a program that can count all the ants in the ant kingdom. This isn't just any ordinary assignment, it's designed to challenge you and make up a significant portion of your continuous assessment here. I've noticed that some of you have been putting a lot of effort, and I truly appreciate that. However, I've also observed that others are still coasting along, sticking to the bare minimum of classroom activities. Let's change that, shall we? In this class, I have valued creativity and innovation. I want to see idea come to life here. I want this to be a space where new solutions are born, where you push boundaries and think outside the box. That's why I've decided to select three of you based on your progress and efforts to collaborate with me and come up with a solution together. This will not only help us move forward but also set an example for the rest of the class to buckle up. So let's get to work and make something remarkable. I've selected three questions that are viable in this program to maybe put a clarification to it, and also I'll publish some part of it. One of the person that asks one of the critical question is Alan Mark. Why should we want to write a program that can count ants in their kingdom? This is where it all starts from asking key questions, and it begins to imagine a world where tiny architects rule their miniature kingdom. I hope you understand what I'm referring to. They build their empires beneath our feet. Now picture a program that is a computer program so precise it can count every ant in their bursting domain, unraveling the secrets of their population, behavior, and survival. But definitely, to the average person, this might seem unnecessary. However, for a biologist, it holds significant value. Developing a system that can automatically count and analyze the population of a given ant colony as an innovative approach to understanding their living environment. Such a system could provide insight into the ants' ages, roles, causes of mortality, and how birth and death rates impact their overall population. Creating a population that can observe, track, and analyze their lives and population would represent a major scientific breakthrough apart from just estimating it. As a data engineer, your goal is to devise solutions to complex data problems through automated process and systematic analysis. This project exemplifies how technology can be leveraged to uncover new knowledge and advance our understanding of the natural world. Donald Vine asked a key question over here, and how he asks on how an algorithm can accurately count an ant without repetition, given their similar appearances, collective living, and constant movement within colonies. This is a very sensitive question I want to take, and it's remarkable for him to think that way. I know that right from the time we were structuring this program, he has been kind of asking such questions on how it could be done. So, this indeed a complex challenge. Yes, I've said it, but it can be addressed through a combination of advanced technologies and innovative approaches. The solution lies in integrating computer vision, machine learning, and a 3D imaging to create a robust system capable of distinguishing and tracking individual ants, and the use of a high resolution camera that can capture detailed images of ants, while machine learning models train and annotated data sets that can identify subtle differences in size, shape, or movement patterns to reduce the risk of duplication. We have not copied any of these innovative ideas from anywhere. We are just doing it on ourselves. So we don't have a way of quoting it. So we are trying to research on our own and see how this is going to be accurate. Then, however, the real breakthrough comes with the use of 3D imaging technology such as LiDAR or depth sensing cameras, which provide depth perception and allow the algorithm to differentiate between ants that may appear overlapping or clustered in 2D images. Then we have the motion tracking, which is another critical component, as ants are constantly on the move. By analyzing these trajectories in real time and assigning unique identifiers based on movement paths, the algorithm can avoid double counting even in densely populated colonies. Additionally, machine learning can be used to recognize behavioral patterns such as trail following or clustering around food sources, enabling the system to predict and account for group dynamics. To ensure accuracy, the algorithm must undergo rigorous validation and iterative improvement, comparing its counts with manual observations and refining the model over time. This process not only enhances reliability but also builds confidence in the system's ability to handle the complexities of an ant colonies. Beyond the technical aspects, this endeavor holds significant scientific value. Accurately counting ants provide insight into their population dynamics, behaviors, and ecological impact. It allows researchers to study their survival strategies, responses to environmental changes, and roles within the ecosystem. For data engineers and scientists, this problem exemplifies the power of combining cutting edge technology with creative problem solving to address real world challenges. While previous efforts, such as those addressing grasshopper invasions, demonstrated the potential of 2D imaging and the integration of a 3D imaging and advanced tracking technicalities elevates this work to a new level. By embracing these tools, you and I know that we can unlock a deeper understanding of ants and by extension the broader natural world. This project is a testament to how innovation can transform seemingly simple tasks into groundbreaking scientific achievement. Then there is this guy, Malu CR. He's always, that is the money guy who comes in as he likes and all that. So he asks, what is the budget? I know you can finance it. So let's look at designing a program capable of accurately counting ant population in their kingdom requires a combination of advanced software development, and potentially biological considerations, including time investment, as antibiotics for controlled environment might, if applicable. Below is an estimated budget breakdown for such a project. I'm not going to tell you cost, but I'm going to tell you the total hardware and equipment that depends on your region. If you want to be part of it, we can remotely teach you on how to go about it and tell you the kind of hardware you are going to use. We need the high resolution cameras to capture detailed images of ants, sensors, high resolution camera that is fitted with macro lenses, which are essential, including computing hardware, high performance computer or server to process images, run machine learning models, and store data. We have the 3D imaging or LiDAR sensors for depth perception and accurate tracking in 3D space. Then we have environmental setup. You have to go to where it is secure. You don't go to where you will be kidnapped. For those who are from Nigeria or some other African environment that you could easily be kidnapped. So if ants are studied in a controlled environment, an artificial ant farm must be set so that you will not risk yourself. Material for creating the habitat may be required if you don't have ant hill or ant kingdom around you. Then we consider the use of antibiotics, which is optional if the study involves controlled bacteria or fungi. in the ant colony. Antibiotics or antifungal agents may be needed in order to simulate some of these food for the ant and all that. Let's go back to the number two, which is software development. It's include machine learning model development. Training a machine to recognize and track ants requires significant computational resources and expertise. We have algorithm design and implementation, developing the core algorithm for counting, tracking, and analyzing ant population. We have the user interface, which is optional if the program requires a user-friendly interface for biologists or researchers. We need additional development costs that will be applied, And labor and expertise, we will not just do things like that without having a pocket motivated. Data scientists and engineers need something, or probably we might go to other department in order to hire biologists and the professionals in particular fields apart from us to come and help us develop these things. We cannot just do this by ourselves. So we have the biologists that have already said, biologists or entomologists, counting expert to provide insight into behavior and validate the program's accuracy to see whether we've done anything achievable. So it's going to be under development. So miscellaneous cost, testing and validation, field testing, data collection and iterative improvement. Maintenance and updates, we have to keep working and observing this data that is growing for quite some time, and these things, logistics have to be involved and all that. So the total budget estimate is like going to be from $113,000, or if it is a low budgeted fund, you can manage $48,600. So then the key considerations after all this said or done is that the budget can vary significantly depending on the scale of the project, the complexity of the ant colony being studied, and whether the program is intended for research or commercially used. If the project is conducted in collaboration with academic institutions or research organizations, some costs, example, labor, equipment, and the risk may be reduced through grants or shared resources, because on this case, if we want to opt in for the second grant, we have to write to the HOD and he has to approve it. Then antibiotics are included as an option, as I said before, assuming they are necessary for maintaining a controlled environment. These artificial ants, if not required, this cost can be excluded. If you have an ant colony that is much in a farm in particular, you have to. Then the budget provides a comprehensive framework for designing a program capable of counting ant populations accurately and efficiently. Malaysia will be ready. Will need about $113,000 from you to start the program. Thanks. See you next class.